the circuit shown below, the switch is closed at t equal to 0. Determine di by dt, d square I by dt square, d cube I by dt square at t equal to 0 plus. This is the given circuit. This is series RLC circuit where switch is closed at t equal to 0. We need to find current, its first, second and third derivative. So it is said that the switch was open at the beginning. Therefore, we can say I of 0 minus is equal to 0, which is nothing but I of 0 plus. So therefore, I of 0 plus, that is immediately after closing the switch, current in the circuit is 0 amps. So since the switch was opened since long time, voltage in the capacitor, that is initial voltage in the capacitor, is also 0. That is Vc of 0 minus is equal to 0 volts. So therefore Vc of 0 plus is also equal to 0 volts. Okay, now we'll assume that at t equal to 0, switch will be closed. That is, switch is closed. When switch is closed, current will start flowing into the circuit. Now let me apply KVL to this circuit. That is, apply KVL to above circuit, so that I can write 10 is equal to 10 into I of t plus voltage across inductor is L di of t by dt. So here L value is 1, that is 1 into di of t by dt plus voltage across capacitor is 1 over C integration of I of t. C value is 1 micro, that is 1 upon C. C is nothing but 1 into micro, that is 10 power minus 6 integration of I of t into dt. So now at t equal to 0 plus, this equation 1 can be written as 10 is equal to, we have 10 I of 0 plus we have di of 0 plus by dt plus, so this is nothing but initial voltage, that is Vc of 0 minus, so Vc of 0 minus value is 0, therefore Vc of 0 plus will also be 0, that is Vc of 0 plus. This is nothing but Vc of 0 minus, at t equal to 0 plus it will be Vc of 0 plus. So simplifying further, I can write 10 is equal to 10 into I of 0 plus is 0, so it is 0 plus we have di of 0 plus by dt plus Vc of 0 plus is 0, so it is 0. So therefore we can write di of 0 plus by dt is equal to, we have 10 ampere per second. So we found I of 0 plus and first derivative of current. Now let's calculate second derivative of current. Let me differentiate equation 1, that is differentiate equation 1, we get, so differentiation of 10 is 0, differentiation of 10 is 0 is equal to, we have 10 I of t, that is 10 di of t by dt plus differentiation of this term is d square I of t by dt square, d square we have I of t by dt square, and differentiation of this will be 1 over c, that I will keep constant, into differentiation of integration will get cancelled, it will be I of t. So that is I of t. Let me call it as equation 2. Now at t equal to 0 plus, this equation can be written as 0 equal to 10 di of 0 plus by dt plus d square I of 0 plus by dt square plus I of t is, that is I of 0 plus divided by 1 into 10 power minus 6. Let me simplify. 0 equal to 10 into di of 0 plus by dt. So already we found di of 0 plus, which is 10. So this is 10 plus we have d square I of 0 plus by dt square plus I of 0 plus is 0. So this entire term is 0. So therefore we have d square I of 0 plus by dt square is equal to 10 into 10 is 100. Take on other side, it will be minus 100 ampere per second square. So this is second derivative of current I of t. So now let's calculate third derivative of current. To get third derivative of current, we supposed to differentiate equation 2. That is, differentiate equation 2, we get, that is, differentiation of 0 is 0 is equal to, differentiation of this is d square I of t by dt square, 10 d square I of t by dt square. We have plus differentiation of this is d cube I of t by dt cube plus constant 1 over c, that is 1 into 10 power minus 6. Differentiation of this is di of t by dt. Now at t equal to 0 plus, this equation can be written as 0 equal to 10 d square I of 0 plus by dt square plus d cube I of 0 plus by dt cube plus 1 upon 1 into 10 power minus 6 di of 0 plus by dt. Now let me substitute the values. 0 equal to 10 into, so d square I of 0 plus value is calculated, that is minus 100 plus this is kept as it is, plus we have, so already we have found di of 0 plus, which is 10, that is 10. So therefore I can write d cube I of 0 plus by dt cube is equal to, we have 10 into 100 is minus 1000. Take on other side, it is 1000 minus 10 divided by 1 into 10 power minus 6. So simplifying this, we'll get minus 9.99 into 10 power 6 volt amperes by second cube.